Okay, in this video we're going to talk about adding vectors. Another way of adding vectors is to say finding the resultant. Finding the resultant of two or more vectors. Here's where this type of thing is kind of important. Let's say that I was flying a plane, so I'm going to kind of draw a plane in here. This is a top view. So here's my plane, and I'm flying it straight east. So my plane is going this way east at 100 miles per hour. But it's in a wind, and the wind is going back this way, let's say 50 degrees north of west at a velocity of 40 miles per hour. So what's going to happen? Well, it's going to slow me down a little bit because it's pushing backwards against me, and it's also going to push me to the north. So I have to figure out where that plane is going to go. And I might have some idea, so it's going to push me a little bit to the north, it's going to slow me down. I'm going to end up going someplace in between the two. That's my actual path that I'm going to follow. But we have to figure out exactly where we're going to want to go, okay? And in order to do that, we add the vectors, okay? And in order to do so, we sketch the situation like we did here, okay? Now, the next step says move the vectors tip to tail. If I was to draw a vector, the pointy end is its tip, and the back end of it is its tail. And if I look at my two vectors here, I'm going to redraw them, okay? So I don't have to draw the plane. I'm just going to draw the two vectors. I have 100 this way. I have 40 this way. And I have an angle of 50 degrees over here. You'll notice right now these two vectors are touching tail to tail. The two tails are touching each other. And I have to move one of the vectors so that they're tip to tail. Now there's two ways I could do it. I could either move the 100 upward so its tail is at the tip of the other one, or I could move the 40 over. In this case, I'm going to move the 40 over so its tail is at the tip of the 100. So I'm going to move the 40 this way. So I'm going to move the 40 that way. And when I do that, I'm going to end up with something that looks like this. Now I have the 100 here, and when I slide the 40 over, it has to be pointing in the same direction. Okay, so it's going to look like this. I'm going to label that as 40. I'm going to label my angle here as 50 degrees. So it's still pointing up 50 degrees. And now, this is sometimes called the parallelogram method because see how the two 40s are parallel? If I had the original 40, you don't have to draw this in here. But if I had the original 40 here, it would be like this, and I end up with a parallelogram. So in math class, sometimes they say to draw a parallelogram. I'm going to get rid of those just a moment. So now I have the vectors, so they're tip to tail. The tip of the the tip of the 100 is at the tail of the 40. The next step it says to do is to draw in the resultant from the origin to the tip of the last vector. So here's my origin, that's where the plane was, and then I draw from there to the tip of the last vector. So it's an arrow always pointing away from the origin. It's going to look like that. I can label it R for the origin. Now, we said back here, okay, that it was going to go kind of up and right. And if we look, our resultant is pointing up and right. So we know we have the diagram right. Now, to find the actual magnitude and direction of the resultant, okay, to actually get the answer, there's a few things I could do. I could do a scale model, okay, use rulers and protractors and measure things out. I could do it in a method called using components, and we're going to talk about that later. In math class, in pre-calc, they might use the law of cosines to do it. Okay, for the law of cosines, I could find R using that in this triangle. We're not going to do that in here. So we're going to concentrate on scale models and using components. So at the top of the next page, we're going to do some examples of finding resultants using scale models. Actually, at first, we're not even going to have to use a scale model because they're pretty straightforward. Okay, now I've switched. I was doing speeds like miles per hour. We talked about displacements or vectors. Another thing is a force. A force is a push or a pull. And direction is going to be really important because if I push you to the right, you're going to behave differently than if I push you down. And in this case, I have two forces, a 20 and a 30, both acting on the object, okay? And I want to find the resultant force. So if they're both pushing to the east. So here's my object. and I have a 20, and I have 30 working in the same direction, and I want to know what the resultant force is going to be. Well, right now they're tail to tail, so if I was to draw them tip to tail, it might look like this, and I can choose to move the 20 or the 30. Maybe I'll move the 30. So here's my origin. I have the 20, and then I'll move the 30 to the end of it. Now my resultant is from the origin to the tip of the last vector. So there's my resultant. And how long is that thing going to be? I don't have to draw it to scale to know that that is going to be 50 newtons. So it's pretty straightforward, and it makes sense. If they're both pulling in the same direction, they're going to work together, and you're going to add them. Okay, so we're going to make a note of this. The maximum resultant is when they're in the same direction and you add, all you have to do is simply add them. Now, the next example, 20 newtons east and 30 newtons west. These are going to be opposite directions. So I draw my object. Okay, I have one thing pulling on it 20 newtons to the east and something pulling on it 30 newtons to the west. Now again, these are tail to tail. In order to add them, I have to make them tip to tail. So I might move the 30 again. So here is my object. I have my 20 going this way still. And then I'm going to move the 30, so its tail is at the tip of the 20, so I'm going to move it over to here, and my 30 is going to go back this way. My resultant is from the origin to the tip of the last vector I drew. Okay, and that's obviously going to be 10. So my resultant for this one is going to be 10 newtons west. And that's the minimum I could get with those two. The minimum resultant is when they're in the opposite direction. And to get the resultant, you can just subtract them. So you don't really need to draw them out like I did. That was just to show you what's going on. If you have a 20 and a 30 going in the opposite direction, you know the result's going to be 10. You just subtract. Now, 20 east and 30 north. So I have my object here. I have a 20 pulling on it this way, and I have a 30 pulling it up this way. Okay? I know it's going to go off this way in between them somewhere. To find out exactly why, I have to draw them tip to, or exactly where, I'm going to draw them tip to tail again. So I'll move my 30 again. So I draw my 20. They're tail to tail over here, so I'm going to move the 30 so its tip is at the tail of the 20. I'm sorry, its tail is at the tip of the 20. It's going to be like this. Then I draw my resultant from the origin to the tip of the last vector I do. So from here onto here, label it resultant. Now, these are at right angles, so I can do Pythagorean theorem. R squared is 20 squared plus 30 squared. Okay, if you want to do this out on your calculator, you can. And I'll give you the final answer. And I got 36.1 newtons. Now, I also have to tell a direction. So I'm going to have to try and find this angle right here. But if you look at your triangle and you remember your trig, the 30 is the opposite side, and the 20 is the adjacent side. Opposite and adjacent, that's tangent. So tan of theta is opposite over adjacent, so it's going to be 30 over 20. To get rid of the tan, I do inverse tan, so theta is going to be tan minus 1 of 30 over 20. And then I use my calculator and I 56.3 degrees. And then my reference line, I can think of this as being my reference line going east. So I went 56.3 degrees north of that. So north of east. I can't say northeast because northeast specifically means at a 45-degree angle. So I have to write it out that way. So if they're at right angles, you don't have to draw a scale model. You have to do a little bit of Pythagorean and some trig. Now our last example is where we have to do the scale model. I have 20 newtons east and 30 newtons, 40 degrees north of east. So I'm going to draw in my origin here. And I'm going to draw the 20 east first. That's going to be pretty straightforward. I'll slide my ruler over. And let's say I'm going to use a scale of 5 to 1. Maybe I want to make a note of that. Scale is going to be 1 centimeter is 5 newtons. All right, so I would have to make, for 20 newtons, I would have to make that 4 centimeters long. And 30 newtons is going to be 6 centimeters long if I use a scale of 5 to 1. So I'll draw the one going in east first. It has to be 4 centimeters long. So I'll start here and draw 4 centimeters long right there. And then I will label that 20 newtons. Now I have to do the other one. In order to do the other one, I have to mark out 40 degrees north of east. So this over here is east, and I have to swing 40 degrees north of that. So I'll take my protractor and slide it over so that its origin is at the origin here. And I'm going to mark 40 degrees north of east, so that mark is going to be right here. And then, so I manipulate my ruler, and then now I'm right along from the origin to that dot I marked for 30 or 40 degrees. I draw it 6 centimeters long. I'm going to label that one 30 newtons. And this was 40 degrees. Now, as I look at these, they're tail to tail, and I have to make them so they're tip to tail, so I have to move one of them. I'm going to take the 30 and move it to the end of the 20. In order to do that, I have to measure out the 40-degree angle again. So I'm going to take my protractor and move it up. So now I put it at the tip of the 20 newton, and I have to mark out my 30 degrees again. So, or 40 degrees. So I'm going to mark that in red here. Okay? Now I have to take my ruler and put it along here. So I put it so it's right along that 40-degree mark again. And I'm going to draw 6 centimeters along that line. So 6 centimeters along that line is going to take me to right about there. Get the ruler out of the way for a minute. And then my resultant, I'm going to arrow on that. That's the vector. So there's my 30 newtons. I'll label that. And then my 40 degrees down here, I'll label that as well. Okay, now my last step is to draw in the resultant. And you draw the resultant from the origin back here to the tip of the last vector you drew. So it's going to be way over here, like so. All right, now how am I going to figure out the magnitude, the size of it, and the angle? Well, for the angle, I can just use my protractor to measure. So I'll slide the protractor up. And I'm going to get, say, about 23 degrees. So I'm going to make a note of that the angle is 23 degrees. And then for the magnitude or size of it, to get the size of it, I have to use my ruler. So I'm going to do that. I'm going to take and slide my ruler along here. Okay, and it looks to me like the length of that is just about 9 centimeters. So I'm going to write down 9 centimeters. But remember, my scale is 5 to 1, so I'm going to multiply that by 5 newtons. 1 centimeter, and that's going to give me 45 newtons. So my final answer is my resultant is 45 newtons. And you remember we had the angle down here was 23 degrees, so 23 degrees, and I swung north of east when I measured that angle. So that is adding vectors using a scale model. Okay. So let's remember that if they're both pointing in the same direction, like in A up here, that's going to give me the maximum resultant, and I can just add them up. Okay. If it, like in B, they're going opposite directions, it's the minimum resultant, and I subtract them. If they're at right angles, I can use Pythagorean, but if I have something besides 180 or 0 or 90 degrees, like this 40-degree angle, then I have to draw it to scale.